Hello, I'm Garrett Sippel, and this is my final project for computer vision. I was attempting to find similar images in a data set. The first way I tried to do this was to find the Harris features of the two photos I'm comparing to see if they're similar to one another. And I did this by looking at the 50 strongest Harris features, and then I looked at a window around the Harris features and compared them in both photos. So I used a squared sum distance around the windows. I enforced uniqueness, so every corner could only be mapped to another corner, and I did that by choosing the min of each of them, and all of that is in this function called compute similarity, but it returns the average squared sum distance of all the corners. And then I looked at the 5 closest images, and hopefully they would be similar images. This actually didn't work very well, so I tried other methods. The second thing I tried was something that was kind of already implemented in MATLAB called image indexes, or index images. And the basic idea of this that algorithm was to use find SIFT features and then use clustering to group them into similar images. This actually works really well, but because it was such a canned approach, I decided that I should try to do more work, or try to think of my own way. But in the meantime, I was trying to come up with ideas to sort the images between containing or being a man-made image, like a photo of a building or a city, or if it's an outdoor image. And I thought that man-made images might be smoother in certain sections, as in a wall might be all gray, and so there wouldn't be a lot of change in the color. So what I did was I passed a window over the image, and at each point I calculated the variance of that window. And actually before I passed the window over, I first put it through a clustering algorithm, because I thought noisy things would not cluster very well, and smoother things would cluster better. So this actually didn't work that well either. But one thing I did notice is that it's actually pretty good at, even though it's not very good at finding the difference between man-made images and natural images, it's pretty good at finding, if there's a lot of smooth parts in an image. So it'll detect the skies, for instance, and a lot of like close-up shots of foliage are kind of, they're messy, so they do get kind of put in their own way. So if I go to this, then I say which method should be used to find objects, then I go to average variance threshold. That's what I'm talking about now. So most of these algorithms are saved already. So this is just this is the results of, so you see this is up below the threshold, so this means there was a low variance, so there's like a lot of skies, and the pool scenes where there's a lot of gray and then a lot of blue. And then also these far away shots of landscape kind of tend to be more similar in like sections. And then above the threshold, and the threshold was kind of arbitrary, but there's a lot more detail in these photos. So there's so it does do an okay job at of picking that out. So then I thought, and then I was thinking about clustering algorithms, and then I already had this algorithm that would find this variance value for me. And I had the idea that maybe I should try to cluster the images on this value. And that actually worked okay. So I ended up deciding that to find similar images, I would cluster on them. So to see similar images, enter 1, and then these are the 3 different methods I have to do it. So number 3 is what I'm talking about right now. And so this is just saying enter an index of a photo you want to see similar photos of. So I don't know, I'll just pick something, I guess 80. And so it actually did an okay job. I would say that those 2 images are pretty similar. It seems to be the same scene. So I did a little bit more than just use that variance value on my clustering, though. I also used the Harris algorithm again to find where the points were, and I took the average. So to create this feature vector that I clustered on, I have my variance value, but then I also have the Harris features, which is put them all in here. Okay, so there's the average variance, the count of the number of corners that it found from the Harris algorithm, and the average strength of them, and then the average y-coordinate and the average x-coordinate of the corners. And so clustering on those things worked pretty well. The one problem that this algorithm does still kind of have a problem with is that images that aren't very similar to one another, or photos that are unique, tend to get grouped with another photo. I used agglomerative clustering, so I was able to provide it with a max number of classes as a input, and I'm actually not using 2 here. It's actually using this in the script that I just showed. But the problem is that it pretty much always wants to use all of the classes that it can. So even though I'm providing it a max number, it tends to just use all of the classes that I allow it to. So I think that's pretty much everything. The last thing I didn't cover was average. Oh, right. So this is basically the same concept for trying to find indoor and outdoor images, but I used my clustering method instead of just variance that I used. So basically I just only allowed 2 classes, hoping that maybe it would group them into some kind of an interesting class. But it pretty much just gives the same thing as when you use a threshold for that variance value. So unfortunately that wasn't very interesting. But so that's my project.